So, hello, everybody. Good morning. And let's start the section two of the SRv6 Ops working group meeting. And this session is being recorded. And first, let's see the note while. By participating in the IETF, you agree to follow IETF processes and policies. And for the meeting tips, please make sure to sign into the session through the data track if you are in person now. And for the remote, and please make sure your audio and video are off. So for the administrative and please use the mail list and wiki and or GitHub to track documents. Today's agenda is very tight. We have 7 maybe the presentation. Let's go for the first one. Michael. Michael is here. Yeah, yeah, please. Yeah, no. Yeah. Okay.
All right, so we continue to make slow and steady progress on this deployment draft, taking your comments into consideration. We did update it for Shenzhen. Can't see the bottom of that slide, unfortunately, but these are the changes that we made, again, based mostly upon your comments. We made it a little bit less MPLS focused. The initial goal of this draft was to help customers being able to know how to migrate from existing MPLS, SR MPLS to SRv6. It was brought up last meeting by Nick Morris that we may want to consider some other encapsulations such as VXLAN. So in the abstract, in the introduction, we kind of made it a little bit more generic. So it's not just solely MPLS to SRv6 focused. So we changed some of the wording. The draft is still very MPLS, SR MPLS heavy, but it's getting less so. We also rewrote a section about gradual versus direct evolution. There's a section in the draft where you can gradually migrate from MPLS to SRv6 by using an interim step going to SR MPLS. That was particularly helpful when SRv6 wasn't yet a standard and it wasn't widely available on platforms. But that's less so now. There's less a reason to do that. So we made it so that people can understand that both a direct migration from MPLS straight to SRv6 without going to SR MPLS is viable, and the gradual migration is also viable. But the cleaner single step architectural direction of just direct migration is typically preferred. And then we included a new VXLAN section based upon Nick's suggestion. So here's just a brief overview. We recommend looking at this section. It's similar to other sections that we had in this deployment draft. Basically, in the migration process, the VTEPs will be upgraded to SRv6 to be able to encapsulate the VXLAN, Ethernet VXLAN, UDP, IP packets. And the line in the middle is to just show that that existing VXLAN tunnel is still continuing, but you can upgrade the core, upgrade the VTEPs with SRv6, and then you can slowly migrate the traffic away from the VXLAN tunnel towards the SRv6 core. And we created some steps in this as well. We haven't performed this migration. We don't know of customers who have. We have plenty of experience with people who have done so from MPLS. So if any of you have experience or know of this, we're kind of taking a stab at what some of the migration steps are, but they're probably pretty obvious. And you can look at the draft to kind of see what we've done. But basically, again, you're upgrading the VTEPs to support V6 and SRv6 encapsulation while you're continuing VXLAN forwarding. You assign the SRv6 locators and SIDs. You deploy SRv6 in the core. Um, you steer some of the VXLAN traffic over to SRv6 transport paths. Um, and then you migrate eventually all the traffic over to those paths, and then you're able to validate the flows and then eventually decommission the VXLAN encapsulation. So thanks again to Nick Morris for suggesting us to use different encapsulations besides just MPLS, SR MPLS. And so here's our next steps. We're going to keep making progress. We're not in any particular hurry with this draft to make it progress beyond this working group. We'll know when it's ready to go. It's already proved helpful to be able to send to customers to say, here's some ideas on how you can migrate to SRv6. Drew last time made this comment, it may be it may be helpful to also show how you can migrate certain areas of your network at a time when you can't migrate the entire network to SRv6. We mentioned that, but um, we will include that in the draft. We've been needing to do so for a little while now. It takes a little bit more effort to do that. So that's really it. We welcome any comments or questions about this draft. Thank you.
Yeah, one quick question. So you mentioned the migration from VX line to SRv6, right? Have you done some tests in lab?
No, yeah,
Okay.
we have not done. We have zero experience with this. We're just kind of, if someone wanted to do this, this is how we think you should do it. But that's a good idea. We should.
Yeah. Do you think there are some potential benefit if we upgrade VX line to SRv6? Could we get some advantage?
Yeah, the advantages would be similar to other, is when you're upgrading from MPLS to SRv6, with VXLAN, you've got your Ethernet frame, you've got VXLAN, UDP IP header, and you're able to get rid of all that and just do that encoding within SRv6. So it makes it much more simple. And then you've got the programmability aspect of SRv6 that just makes it much more programmable, because then you've got you can just use a layer 2 SID within SRv6, which just replaces the need for VXLAN. So it just simplifies the network. Yeah.
Pawan Biram, HP. I apologize, I haven't read through the draft, but I just wanted to ask if this draft also covers migration from, say, a bandwidth engineered RSVPT MPLS network to SRv6. Is that in the scope of this?
The scope, yeah, it could very well be, and we probably should expand on that. What we're currently covering pretty dang well is MPLS to SRv6.
Okay. So there is this RFC 8426 that talks about RSVP and SR coexistence as an intermediate step to migrate from RSVP to SR6. I would encourage you to take a look at that and then see how that can be fed into this.
Do you happen to know that offhand? The RFC?
8426.
8426. Okay, thank you. Yeah. Thank you.
Thank you so much. I kind of agree with what Pawan was saying. I think that's a very good addition to the document. For the VXLAN one, I think we can also reach out to our colleagues in maybe BES and NVO3, as especially when you were saying that we want to verify what we have written in this step is making sanity check.
Yeah.
It's a working group adopted document. I think I would prefer if you only send, but if you need chair's help for anything, please reach out.
BES.
For BES and NVO3. Is there any other group that people can think of where we could share this information, especially with respect to migration? And I guess I think those are the two groups that comes to my mind.
Great. Thank you.
Thank you.
Thanks.
Okay, next presentation is Yeah, from Yisung. Yeah.
Good morning, everyone. I'm Yisung Liu from China Mobile, and I will present the considerations for the traffic steering to SRv6 on behalf of my co-authors. Firstly, this is the summary of the traffic steering methods. We have mainly two types. The first one is based on the destination address, and the second one is based on the flow characteristics. I will introduce one by one, but I will fast to of that. The first one, the first subtype of steering method is that the static route. The packet destination IPv6 address can match the IPv6 route static with the next hop, so to the SRv6, like in the fig, we can see the example. So that's simple. The second subtype of the based on the destination address is the IGP shortcut. That means the head node treats the SR6 policy as a direct link to the endpoint. When the IGP shortcut feature is enabled and the SRv6 policy status is up, so the head node will automatically generate a route to the policy's endpoint address that will point to that policy. If the SRv6 policy goes down, so the route is withdrawn and the traffic will fall back to forward with the SRv6B like that. The third subtype is that based on the color-based. We leverage the BGP route with the color extended community and the next hop address. The head end on the head end, the route will match to the SRv6 policy with the same color and the endpoint. And the traffic destined for that route is forwarded to the matching SRv6 policy. The fourth subtype of the destination address is that based on the bounding seed. When a packet destination IPv6 address matches the bounding seed, the bounding seed means that it will indicate that SRv6 policy, and the packet will steer into that policy. And this allows the seamless concatenation of the multiple SRv6 policies without insert the full seed list. It can reduce the encapsulation overhead. So let's move to the second main type of this is the first subtype of the based on the flow characteristics based on the DSCP. For this method, we we design the scenario. We first we build a SRv6 policy group that group is created for given endpoint. With the same point, so in the group, we should configure mapping rules. That's the DSCP value to the color. In this example, the DSCP 10 maps to the color 100, and DSCP 20 maps to the color 2000. So we can use a tunnel policy to steer the traffic matching the destination to the SRv6 group. So the DSCP value in the packet can determine which specific SRv6 policy. So that will allow the different queues classes for the same destination prefix. The second subtype is the based on the 802.1p. This steering traffic based on the 802.1p priority value in the VLAN tag. That's for the Ethernet traffic. It is almost identically to the DSCP-based steering. but the difference is that it will use the 802.1p field as the classifier. So it also requires a SRv6 policy group and a tunnel policy to direct the traffic to the group, and we should configure the mapping rules with the group, and the 802.1p value mapped to the color. The third subtype is that based on the service class. This is the local device identifier that will applied for the unmarked traffic. And well, that means the traffic, the packets don't carry the DSCP or the 802.1p information, etc. So the traffic is first classified locally and marked with a service class value. And we also should configure mapping rules for the service class value to the color. The fourth subtype is almost the same as the service class. That means the T class. The T class also a local identifier, and but it can support a much larger range compared to the service class, and it can support more service the differentiation. So we also should configure mapping rules for the T class value to the color. So the fifth subtype, also the last subtype of the method, is that steering via the BDP flows back. And the controller-based method for the flexible global traffic steering. A central controller defines the fine-grained traffic matching rules. The controller will distribute these rules as the BDP flows back route to the head node. So the flows back route include actions such as setting the color and the next hop for the match traffic, and it will enable the dynamic and the centralized control over the traffic steering. So this is a summary of the all of these specific methods for the key point and the characteristics. So that's all. This is the first presentation of this draft. We see more review and feedback from the working group. Thank you.
Any questions or comment? Support? Agreeing?
We were just discussing this in the chat as well. This felt as if everything that we have defined, all the options in the summary is applicable to SR policy in general, like both for SRMPLS as well as SRv6. Our charter is only for focusing on SRv6 operations. For any generic operations, it is in the Spring Charter. So we have Spring chairs as well. Any thoughts from them? Should we send them your way? Is the content looks good. I think it's a good collection of various the techniques, and if operators wants this to be in one document, according to me it will fall under the Spring Charter.
Bruno is my name. No. Alvaro Rotana, Spring Chair. I'm going to defer to whatever Bruno says. You're going to get up and say something? Yes. So what I was going to say is, yes, if there is a combination of things, it belongs in Spring. I agree with that. Now, having said that, I have noticed in Spring a trend lately in many of the authors wanting to split the drafts in two. I don't know that it makes sense for this draft to be split in two, but I'm just saying that this is the inverse of the trend that we've been noticing. The important thing in Spring is going to be engagement from the mailing list. So if you want to post something to the Spring Working Group and see if we can get engagement, um, we can do something like that. We don't have any more time this afternoon in our meeting to talk about this draft, but send it to the list and see what happens. We can't make any promises.
Quickly, could you just elaborate, splitting in two, what would be part one and what would be part two?
So we've seen several of the drafts in Spring that cover both SRv6 and SRMPLS. And so some of the authors, for example, we recently split up the SRMP drafts into what the SRv6 machinery is going to be and what the SRMPLS coverage is. So that's what we've been seeing there.
Thanks. I thought it was like specification part one and then operational part two, but it's fine. Thanks.
If we decide to do that, also, I think we need to update the document. Right now, document says everything is for SRv6, but in reality, when we go through it, it's applicable to both. And of course, then you need to refresh and make sure that that's the content that's being reflected. That's general SR policy rather than SRv6. And if there is something needs calling out, for instance, there is an example in the chat as well, that we can still add a section in the same document that this is specifically to SRv6, which is a good thing to point out.
Okay, thank you.
Okay, so this is just a small update on the draft on the addressing considerations. Most of the work actually done by Jakob, who can't be here this time, so I will present the updates. Let's just do a quick recap of the draft, which already had been presented at the last IETF meeting. So the main goal is to provide operational guidelines for service providers. And that's mainly because it became obvious to us that a good consideration, a good address scheme is crucial when leveraging the actual advantages of SRv6 in general, and in particular when using compressed sits. So design goals we had are simplicity. It's a strong focus on summarization, which seems crucial. And of course on traffic engineering efficiency. So we really can get the advantage of compressed sits. The document really focuses on the major uses. So it's all tailored around the F3216 flavor, which as far as I know is the one which is mostly used. It concentrates on the next CSID flavor, but in both respects is probably applicable to other formats as well, with some adjustments probably. So this is the gist of the actual recommendation. Actually, there are 3 of them tailored for small, what we call small networks, large networks, and very large networks. Small networks could theoretically have up to 57K devices with summarization efficiencies apparently quite some less, but probably cover quite a lot of use cases. And we have some SRv6 CSID block. We suggest a certain placement of some bits for flex algo. And then for the actual node set, we suggest the differentiation in the set ID and the node ID. And in particular, between the set ID and the node ID, we can do address summarization, which helps a lot to reduce routing table and forwarding table size. The recommendations for large networks and very large networks below there, it's basically moving the flex algo bits a bit to the left. So you have place for something called a region and still allow some summarization there. So what changed since the last version? The new version is out since a few weeks. Basically, it's really focused and it's directly reflected that we focus on the next CSID flavor, that the status is informational, and we started to add a short section on IP address management. So that's it. We'd be happy for any contribution, maybe in particular with respect to whether the concepts for small, large, and very large networks seem to be good. And in the end, if all is good, whether it would be time for workgroup adoption.
Yes. So, yeah. Jim online?
Yeah, hi. I'm just any particular reason with just focusing on next CSID and not all of the CSID flavors?
Yeah, that's basically because it seems to us that this is mostly used and it makes it much easier to be direct to the point and have the examples particularly tailored at this. In general, I think, if I understand it right, that the whole addressing scheme would apply to replace it as use it as well.
Okay.
Yeah, okay. I have one question. So currently the next CSID can be also used in data centers, especially for AI data center. We see some use cases here, right? So do you think there is some difference between the current addressing for the WAN network and the AI data center?
I don't see any difference whether it's a WAN network or a data center network. You just have to check whether the size fits. So whether you can use of aggregation and whether the size of the overall network fits. So you have just to pick the right addressing scheme, whether small, large, or extra large networks.
Adding on to what Jim was saying, as an individual document, it's up to the authors. Like you want to keep focused on next CSID, it's completely fine. But now since we are asking for adoption, I would also ask the working group to give that feedback early. If this is a concern for you that the authors want to only focus on next CSID or not, I think we have standardized both mechanisms and it's up to the working group to insist. And if and then as chairs we can do that, but I want that feedback early, so especially people who have done replaced CSID and have deployed it or are active, either please contribute now if you have specific suggestion, and then we can make it generic. It's always best if it is includes both, but if not, that's what will happen. So this is your my suggestion, to please be active and provide text early and don't wait for the last moments. And we have Jim back.
Yeah, just to add to your
answer?
point,
Okay.
just to add to your point.
Jim, just a moment. Martin would like to answer.
Oh.
Just a short comment. I would be happy to discuss the applicability for a replace CSID. If there's really a case in bringing examples for this and to check whether there's a difference or not, I would be happy for any discussion there.
Jim,
go ahead.
Yeah, so just to add to what Drew said, as the AD that's eventually going to get the document, if it's adopted, I would immediately be asking that question. Why not replace CSID? And if the document doesn't tell me why not, then I would be asking the question. So basically, either the document needs to include the both flavors, or there at least needs to be text based on the working group consensus as to why it's not included.
Oh, okay. So point is either include it or have a statement why we don't consider it. Yeah.
Yeah, exactly. I mean, I don't care whether you do or don't. It's up to the working group. It's not my decision. But obviously, to save me asking that question later, it's better to just make that clear.
Yep.
Thanks.
Those are good comment for the mailing list. But is there any other questions or comment?
Yeah, let's go to next one. If any comments, please send the email to mail list. Thank you.
Thanks.
Okay. Yeah.
Hello, everyone. I'm Haiyang from IG3C. Today, I will show this topic, service interworking between SRv6. Okay, for motivation, as operator deploys SRv6, their network are not always a single domain. They often split into multiple AS or administrative domains. The problems arise because the locator roles are not advertised across domains. So this broke the end-to-end service path. Our goal is to describe how to attract end-to-end SR6 VPN service interworking across domains. By adopting the MPLS VPN models offering A, B, and C to SRv6 environmental. It's also supporting BE and TE forwarding. Okay, we use this reference topologies. These topologies, C1 and C2 represent the customer endpoint. P1 and P6 are the ingress and the egress. P is connected to the CE. SVR P1, T2, to P5 are the routers at the boundaries between AS. We are focused on the traffic from C1 to C2, illustrating how the service is maintained across the three AS. Okay, the first is, okay.
Just a sec. Joel, go ahead with your question.
Okay, I want to clarify one aspect of your first two slides. You're showing multiple ASs. If those are multiple ASs under one administrative domain, I can understand that. If those are multiple ASs under separate administrative domains, you may not run SRv6 across them. So I need you to clarify what your administrative and control and trust relationship assumptions are before we get any further into this.
Yeah, yes, Joy, I'm also one cause of this draft. Yeah, you are correct. We need to add some constraint to the text describe what you are saying. Yeah, thank you.
Okay. Okay, for the option A, VRF to IVF, the key idea is that the SVRs trace each other's AS if they were CE routers. They have direct links configured with stub inference bound to specific VIFs. At the control plane within AS, IBTP is used to advance VPN v4 v6 routers and VPN 6. Between SVRs, EBP is used to advertise the IPv4 and IPv6 unicast routes. For forwarding, the SRv is used, the SRv or SRv policy is used inside AS. But the standard IP forwarding is used over the VRF links. This option is simple in implementation, but it have limited scalability due to poor VPN link requirement. Second is option B, VPN routes redistribution. The key idea is that it's ASVRs do not bound VPNs to physical interface. And the VPN 4 and the VPN v6 rules are redistributed via EPP between the SBR. And the traffic is carried over the multi-segment SRv6 tunnels. For SRv6 operation, the SBRs will correct a new local SID mapped to the original VPN SID. And they will advertise this new SID internally within the AS and between the AS. For the forwarding is simple. It's just the destination address replacement. For SRv6 operation, the CBR will use bounding set for SR as a segment list. A new BSID type is needed to allow us to replace the bound set in the SRH header with the next SID. This option avoid the poor VPN interface overhead by redistribution rules via EBP and use SRv6 SID on the BSID translation, and it's offer better scalability than option A. The last is option C, multi-hop EBGP. The key idea is the egress PE direct the vertex VPN rules and VPN set to egress PE in the different layers. They use the multi-EBP between PEs. And for BE, they require locator roles to be advertisement across intermediate AS. Forwarding is simple, just a simple SRv6 in calculation to VPN SID. For BE, if there are a cross-domain controller, the controller can direct programs end-to-end SRv6 process. Without controller, the SBR must resolve the next hop to segment list. And the option C offers the best scalability as it and is require more complex control plan setup. Okay, this is interesting intra-domain interworking hierarchical VPN. This VPN selects the PE function into UPE for user and SPE for service provider. Okay, this good news. This scenario is can use the same mechanism developed for inter-domain option B can be directed to solve the intra-domain HVPN scenario with SRv6. Okay, this slide shows the key difference between the three options and some deployment considerations. Option A is suitable for small deployments and easy to implement, but lacks scalability. Option B have a good balance for operators, but then option C is not have the option C is complexible. Option C is the best for unified network, but it have highly scalable but complex because it require locator routes advertisements. The choice depends on the network size, administration boundary, and the trust model between the AS and the exciting operation models. Okay, that's all. Thank you for your attention. Any question?
Sinan, please see the chat after the presentation. Okay. So let's go to next presentation. Oh, okay, Jim. Sorry, wait a moment.
Yeah, so I'm just going to make a comment based on what I said in the chat. I haven't read the document in detail, but alarm bells are going off in my mind that this is quite potentially more of a Spring remit than SRv6 Ops, if nothing else, for the security aspects of cross-domain SRv6. But I think at a minimum, the SRv6 Ops and Spring chairs should at least have a conversation to determine based on the charters where this would actually sit. Whether that happens now or whether it happens, if there's some desire to get adoption of the document somewhere. But, I don't want to stick my nose in too much, but definitely where this fits in charter, whether it be Spring or SRv6 Ops, is an important question to answer.
Jim, this is Dan. Yes, point taken. We should sit down with the chair and discuss this. It's not the first time that when we talk about boundaries that this point comes up. But
Yeah.
I'm on yeah. So let's tackle a meeting for that one.
Yep.
Yeah. Okay, next one, Jimmy, please.
Okay, hello everyone. This is Jimmy from China Mobile. I would like to introduce a new draft called QP-based SRv6 load balancing deployment. And this draft focuses on combining SRv6 with QP and to aim to provide a refined solution for DCI network management and control. So let me first introduce the motivation behind this draft. And with the rapid development of AI, the inter-DC network traffic no longer limited to simple backup data transfer, but exhibits distinct character of all large bandwidth, low latency, and high burstness. And there are a large number of RDMA Rocky V2 protocol, large elephant flows between GPUs. And these elephant flows are characterized by long-lived, high throughput, and extreme sensitive to latency and packet loss. And meanwhile, in AI cluster, task always lasts for several days, with a relatively stable 5-tuple fields and a highly stable communication pattern, and the flow always bounded to the long-term QP instance. So this causes two main problems. First is link hotspot and congestion caused by CMP escalation. And due to the fixed 5-tuple fields and the presence of elephant flows, multiple similar large will hashed onto the same physical link. And the second is lack of dynamic adaptability. The traffic is bounded to QP instance, so even when congestion is detected on a specific link, SMP cannot dynamically migrate existing long distance flow to the link. So to address this problem, the industry has attempted to introduce finer grained load balancing mechanisms such as flowlet or package level load balancing. However, these approaches introduce complexity related to package reordering, especially in DCI networks. And so this draft proposed a solution. The key idea is simple and effective. So as the QP is a basic unit of RDMA communication, each connection has a unique QP. So even if multiple flows share similar QP, IP addresses and ports, the QP ID will always be different. So we can not only split large flows into finer grained flow using QP, but also we can improve the performance of ECMP scheduling. And so the solution can divide it into two steps. The step one is QP2 policy mapping. The ingress device parses the Rocky V2 package header and extracts the destination QP ID and maps the traffic to a specific SRv6 policy according to the QP ID. And step two is enhanced hash based on SL scheduling. Within the selected SRv6 policy, we can use an enhanced hash algorithm, takes QP as input to perform deterministic fine-grained load balancing and select a specific SL. So let me explain with a typical use case. Here are two DC, DC1 and DC2 are connected by PE1, PE2, and the four physical link P1 to P4. The solution has 3 steps, and step 1 is the controller generate BGP flowback rules that include destination QP, and the BGP flowback route define the matching condition, includes destination source address, destination address, source address, UDP protocol, destination and source port, and especially the most important is destination QP val. And the flowback action is redirect the matched flow to policy 1 to specific policy. And step 2 is map QP ranges to SRv6 policies. And in this step, the ingress PE will receive the BGP flowback route delivered by the controller and generate the mapping list. In this scenario, QP1, QP2 are mapped to policy 1, and QP3 and 4 are mapped to policy 2. And step 3, in each policy, we use 5-tuple plus QP as the hash key to select different paths. QP1 to 4 can hash to the different SL in this step. So the solution has 2 advantages. The first is finer granted traffic steering, and the second is from random distribution to control the scheduling. We can use this for change the we can use this solution that gives the network operator more precise traffic control. And the next step, we want to absorb suggestions from the WG. Okay, I think that is all.
Yeah. Any question? Comments? Sinab? Okay. Yeah, Jeff, please.
I can repeat my comments from Jeff Tensor NVIDIA. I can repeat my comments from IDR. Yeah, I don't think the complexity associated is not worth implementing. Another interesting part, QPAD is governed by collective library. Right? This is where it's coming from. So you need, and it's dynamically, usually you define range of QPs or number of QPs runtime variable, and then it will be auto-generated. So now you need somehow to communicate with host side, I think actually communication library layer, extract QP IDs, get them somehow the controller, somehow figure out the path for them. The amount of kind of interactions is absolutely non-trivial. It's quite dynamic. And again, on top of what I already said, it's enough to extract QP ID during local hashing to load balance traffic. Again, the benefits are arguable. There are results published by Meta last year, and they actually went away from it, in my understanding. So all in all, I understand where you're coming from. I don't think it's worth doing given the complexity. Okay.
Continue this on the mailing list.
Okay. Okay. We will discuss this. Okay. Thank you.
Okay, next one, Feng Yang, please.
This is Feng Yang from China Mobile, and I will represent our co-author to present this slide. The name is SRv6 Policy Selector. Before we started, we just have some quick recap. The motivation for this proposal is that the IETF has specified as a policy protection inside one policy. But there is another policy named which is a composite SR policy. Inside the SR composite SR policy, there will be some constituent policies. The protection among those kind of constituent policy will not be defined. So this will define that. So we have presented this. We have come up with this idea 2 years ago, and we found that this proposal doesn't have any standard extension. So we moved to SRv6 OPS group, and we received comments in last meeting that this mechanism should include both SRv6 and SRKs. So the updates, there are 2 updates. One is SR policy selector, and another is example. So in this picture, we have the parent SR policy, which is another name of the composite SR policy. So we define the SR policy selector in the middle, and that will select different of the constituent SR policy based on the quality measurement. So on the left side, there is a classified traffic. That is actually the customer service. So we are trying to define one SR policy selector for each user service. So the selection is based on the quality measurement, which in here is a threshold, and we have the priority for the selection to break the tie, and from the high priority to low priority if all of constituent SR policy can meet the threshold. So this is an example of we also implemented with SRv6 as the moment. So the first is definition of the service, and there are the step 1 is the definition of the service. There are 2 services which are connecting to each SR policy selector, and the step 2, there are definition of the SR policy, which is which hasn't been any changed. And the step 3, we have the defined how the threshold, like some is latency, some is bandwidth, and we connect the priority with the service. So that's all. The next step, we want to have comments and what we need to do for moving to next step. Thank you.
Okay, let's discuss this document through mail list. We have 5 minutes. Linda, please.
Okay, I'll make it fast. So this is the use case for our draft. So basically, for some services, financial services, when they go through the SRv6, they need ESP protection. So you can see here that they need a policy, the SRv6 policy, SR policy to go through the network. So the policy, the set has to be outside the domain and outside the packet. Um, so what it does is in IDR, we have a draft called SD1 Discovery, showing that when you have IPsec or ESP protected services, you need to basically add the tunnel encapsulation path attribute to indicate the appropriate IPsec ESP related information. In SR, document, we have defined all the sub-TLVs. And here we're just showing how do we use that to allow the BGP to advertise those services through the network. So here's just a snapshot of the payload. I think everybody's familiar with. The only difference is the payload is ESP protected. And however, in the IDR, we don't have this specific tunnel type. We call it ESP protected payload. And IANA has assigned the number here, 28, so that we can use the tunnel encapsulation attribute to pass this specific ESP protected payload through the network. And so that both end knows that for those destinations, they need to do the encryption with the IPsec attributes being advertised by the originating nodes. So here is the detailed information in the tunnel encap attribute. Basically, you have a new tunnel type, ESP protected payload, and underneath this, you can include all the IPsec related sub-TLVs. All those sub-TLVs have been specified in the IDR document. And that's it. Here's putting everything together with path attribute, with set list, and here just showing that in the tunnel encap attribute, we added this specific tunnel type and utilize the IPsec sub-TLVs being specified by IDR. And everything else is the same. Here is just more of the illustration of the process when you have PE1 advertise specific routes which need to be protected by ESP going into the PE2, and then PE2 basically process this BGP update. Whenever they receive a route towards this route, they will be able to apply the encapsulation for the payload. And that's it. This is just the initial draft, and we're looking for more reviews, more comments from the working group. Thank you.
Okay, 1 minute. Any comments?
Trying to find the queue. So good work, but as I texted, I was expecting to see at least an operator on this work with you to because we are chartered for operators and operational experiences, and in operations, what to improve, what to enhance, etc., etc. I don't see that in this document. It feels like it's more for.
Okay, so to explain that is this is really our financial enterprise customers. They are not really service provider per se, so they don't normally come to IETF. But we can definitely reach out for them to be able to charm in and give the requirement.
Okay.
Thank you.
1 minute. I think a general feedback this time, since there were lots of 0 draft, we were a little bit liberal. We were not forcing that it's in our charter or not. We wanted to give people an opportunity to introduce their work. But in general, just a feedback, please make sure that it fits into our SRv6 Operations charter when you ask for agenda. And thank you, Linda.
Thank you.
Okay, thank you, everyone. So let's meet next time, right? Yeah.
In Vienna.
Yeah. See you.
Well, we three are here and present.
Yeah.
We need to have a little chat among with the chairs. So, in my view, any operator could come with their story here, and whatever happens here could feed the spring after, and not go straight to spring.
Yeah. But then the thing is, people should preface it. Like, we are here to get inputs.
Yes.
Only this is not in SRV6, but the draft name is SRV6 Operations.
Yes.
So then you will claim that it belongs in our charter.
Yes, that's true. Well, that's a good point.
I think we could be a little bit more this time. Like we didn't respond to any of them. We can be a little bit more proactive and say, "Oh, by the way, handle this."
I will put a reminder. Good morning.
我有点别的事儿。